Right, number 1, the answer is choice 2. You can simply, because it says which expression is equivalent to, do 2 stores x, type in this, and then type in the 4 answer choices and see which ones match. It's choice 2, obviously. 2, the answer is also choice 2. They want, because they say this, just remember that that means they want you to find x values. And simply you are going to put this into your y1, this into your y2, and see where they intersect. Okay, they intersect technically, it's at x equals 3.8988, and then you round that. So for number 3, the answer is choice 1. So just a couple things real quick. I always like to draw that midline, that vertical shift, and that vertical shift is 5. So you know that the answer choice has to be 1 or 2 because these don't have 5 at the end, okay? And then the last thing that you're going to be looking at is, you can see both of these say -3. So your amplitude is 3, but the negative is insinuating that the graph is going in the opposite direction of what it normally does. So for example, if you look at this graph right here, from the y-axis, I should say, we are going down first. Now this is a sine curve because a sine curve starts, middles, and ends on the midline. That's the behavior of a sine curve. Begins, middles, and ends all on the midline, okay? And so that's why it's choice 1, because it's a cosine curve. And just real quick, a cosine curve, if it was shifted up 5, okay, and then we had a -3, we would be starting here at 2, and it would kind of look like that. Okay, so your cosine curve, if we had a -3 there, cosine curve usually starts up, but here we're starting and we're finishing down. Okay, number 4, your answer is choice 2. Now you can cheat on this, and what you can do is you can do 4 stores x, type in this, and type in this, and you will get -8. So why is the answer not choice 1? Well, the answer is not choice 1 because it says in quadrant 3. And if you plot this point, you are not in quadrant 3, you're in quadrant 4. So then you have to go to the next one. So you can do -3 stores x. Type in this, type in this. You do get -15. And when that happens, then you ask yourself, is this in quadrant 3? And the answer is yes, it is. Now, if you were going to do this algebraically, you could simply take each of these, the x squared minus 24 equals x minus 12, and you can move over both of these. So I'm going to squeeze in a minus x there, plus 12 there. This will cancel out. So I'll have x squared minus x minus 12 equals 0. And you could factor this, okay? And I'm showing you this. Obviously, the easier way to do this when it's a multiple choice is what I already told you. But it may not always be a multiple choice. So you do have to be careful here and make sure you do know how to do all this factoring. So I'm going to get x equals 4, and I'm going to get x equals -3. Then you're supposed to take each of those answer choices and put them back into one of the original 2 equations. I always like that easier one. I don't like to touch that quadratic if I don't have to. So y equals, now x in this case is 4 minus 12. And over here, y equals, and x in this case is -3 minus 12. So this ends up being -15, which matches choice 2. And this ends up being -8, which matches choice 1. But again, we need to be in that 3rd quadrant. Okay, so for number 5, the answer is choice 1. So if you Don't understand that one? Here we go. They're telling you that s is 4, so I'm going to just take that 4x squared, and I'm going to make that minus 12x plus 9. And the reason why I'm doing that is I know that s is 4, so I'm putting in a 4 here, and 3 times 4 is 12. Okay, so you have two choices. We can factor this and see if we get this, or we can take this and watch what I'm going to do with that. So that's 2x minus 3, and that quantity is squared, right? So let me just underline this for a minute. So 2x minus 3, if that quantity is squared, that means we write it twice. Well, why don't we just double distribute here? So that's going to give me 4x squared. This will give me minus 6x. This will give me another minus 6x. And this will give me plus 9. So then I've got 4x squared minus 12x plus 9, and voila, those match. Check. Okay, so now let's look at choice 2, or I should say Roman numeral 2, sorry. So we've got x minus 2, and then in parentheses I have x squared. I'm going to put that 4 in, so that's plus 4x plus 4. Okay, well, this time I'm going to take a different tactic. I could write this x minus 2 3 times and double distribute. That can get a little messy for a lot of kids. So I'm going to go with the other option, which would be to take this and factor it. Well, this is kind of already factored, but this isn't. So let's just keep going with that. So I'm going to bring down this x minus 2. And if I factor this quadratic, I know I get x and x. What multiplies to 4? 2 and 2. And adds to 4, positive 2 and positive 2. Now, if you look at what we have here, I have x minus 2. I've got 2 of these guys, but I do not have 3 x minus 2s. That's what this means. 3 x minus 2s, and I don't have 3 x minus 2s. So that's why this does not work. Number 6, the answer is choice 3. It asks for an exponential regression. So remember, you're just going to take your calculator and you are going to hit Stat, Edit. You'll see that you have a list 1 there, list 2. So all of these numbers are going into your list 1. Those are your x values. And all these numbers are going into your list 2, which are your y values. After you have all of those in, then you hit Stat, arrow to the right to Calc, and go all the way down to 0, I believe it is. And you will see that EXP regression. Keep hitting that. Keep hitting enter, I should say. Whoops. And whoops. Let me just, I don't think I turned my pen on. Yep, there we go. You're going to end up with y equals 40.0037, and then times 1.1963. Now it's going to be to the x, but they want to know how much bacteria we have present after 8 hours. So I'm going to replace that x with 8, and then I throw that in my calculator. I'll get choice 3. So number 7, the answer is choice 2. For a multiple choice, you can mathematically cheat and do 2 store as x. Type in this, get an answer, and then type in this. You will not get the same answer, but if you type in this, you will. Now, that's great for multiple choice, but again, I really think this is something you need to know how to do, so I'm going to show you how to do it. There's 4 terms, so I'm going to group the first 2 and the second 2. So with the first 2, I can take out an x cubed, and then I have x plus 4. With the second 2, please remember, if the first term is a negative, take out that negative. Okay, so I'm going to take out a negative 9x, and then I have x plus 4. So then I take those 2 GCFs, and I smush them together in one set of parentheses, and then the common factor of x plus 4 in the other. Please be careful, this says factored completely, so my x cubed minus 9x is not factored completely. They both have a common factor of x, so I'm going to take that out. That leaves me with x squared minus 9. But x squared plus 9 is the difference of 2 perfect squares, so I'm going to go one extra step, okay, and that's going to be x plus 3, x minus 3, and x plus 4. And there's choice 2. Number 8 is choice 2. Now, again, multiple choice, so you can cheat. So you can do 6 store as x in your calculator, type in the left, type in the right, including the radical, and they should equal one another. So, yay, we know that 6 works. However, notice that choice 3 has another value. So you really should check that. So you should do -4 store as x, type this in, and you'll see that they do not equal each other. So that's why the answer is choice 2 and not choice 3. Again, though, I'm going to show you because I really think it's important for you to know how to do this if it was not a multiple choice. So if I have a radical equation, I really want to get rid of it. So the opposite of square rooting is squaring. When I do that, on the left side, x plus 1 gets written twice. And then this on the right-hand side, the square and the square root cancel each other out. Okay, so on this left-hand side here, I'm going to get x squared plus x plus 1. And then I'm going to get x squared plus 2x plus 1. And then I'm going to move everything always, when you have a quadratic, an x squared term, you always want to get everything to the x squared side. So I am going to move that right side over. Bing, bing. I end up with x squared minus 2x minus 24. I'm going to ask myself what adds to -2 and multiplies to -24. So what multiplies to 24? 6 and 4. And I need for it to add to a -2, so that's how I know that guy is negative and this guy is positive. X equals 6 and x equals -4. Now what you have to be careful of is what we call extraneous roots, okay? So again, why it's choice 2 and why isn't it choice 3? And I'm just going to show you. So we had x plus 1 initially equals radical 4x plus 25. So let's see what happens when I use -4. So if I put a -4 in here and I add 1, do you see that gives me -3? But over here, if I do 4 times -4 plus 25, I end up with the square root of 9. And the square root of 9 is 3. And these guys are not equal to each other. So then we say that -4 is an extraneous root, and we just go like that. And that's why the answer is choice 2. 9, the answer is choice 3. When they talk about which translation of f of x, this equation, this graph right here, would have imaginary roots means how can I move this so that it doesn't hit the x-axis at all. Right now, it's hitting the x-axis in 2 spots. We need it to not hit it at all. So let's look at this one. This, whenever the number is inside parentheses, what that means is we have a horizontal shift, and we have a horizontal shift in the opposite direction. So that's a +5. So what that means is we're actually going to shift 5 to the left. So if I take this and I shift this 5 to the left, so I'm going in this direction, really what's happening is this point here is moving 1, 2, 3, 4, 5 points, 5 spaces rather over here, and so is this. So I'm going to end up with a parabola over there. Okay, so let me just draw that so you can kind of see that. So let me do that again. So we go 1, 2, 3, 4, 5. And then this guy, 1, 2, 3, 4, 5. So do you see that I'm still, oh, that's so bad, but do you see that I'm still hitting the x-axis? That's not going to work. And the same thing over here on number 2. That's a shift 5 units that direction. So this point right here is just going to get shifted over, and this point right here is going to get shifted over. So it's going to look like that. Okay, so it's still hitting the x-axis. Now, if we look at choice 3, that would be taking this graph and moving it up 5. Well, let's look at where this minimum is. Right now, it's 1, 2, 3, 4 below the x-axis. So if I shift this up 5, that minimum is going to be right here at 1. So let me draw that for you. It's going to be right here. That's the minimum. This point right here is going up 5. And then that means this whole thing gets shifted up like that. And voila, that graph does not hit the x-axis. And that's what imaginary roots mean for this particular question. Okay, whereas if we looked at this one, we would be taking this minimum, its vertex, and shifting it down 5. So it would be like down here, and it would still eventually hit that x-axis. Number 10, the answer is choice 2. We have a quadratic because we have an x squared term, so I'm going to take these guys right here, and I'm going to move everything to the left-hand side. So I'm going to subtract 2x, and I'm going to add 3 and add 3. That gives me 3x squared minus 6x plus 5 equals 0. Now, some kids will try to factor this, which I can understand that. But if you look at your answer choices, 3 of these answer choices have i's in them. And the other one that doesn't looks kind of crazy. So whenever I see this, I'm like, I'm not going to even try factoring that. I'm going straight to quadratic formula. My A is 3, my B is -6, and my C is 5. Now you have the quadratic formula. It's on your formula sheet. So it's negative B, which will be a positive 6, plus or minus square root, B squared. That's going to be -6 squared. Please, you must put it in parentheses, because if you put it in your calculator without it, you're going to be getting a different answer, aka the wrong answer. All right, minus 4 times 3 times 5. And that whole thing is over 2 times A. All right, so what I like to do in the next step is I like to take all of this and put it in my calculator. Do not put the radical in. So just open a set of parentheses, type in your -6, close it, blah, 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 blah. Okay, so if you do that, you end up with x equals 6 plus or minus, and that ends up being the square root of -24 all over 6. So I like to just focus for a second on that -24. You can't have a negative underneath a radical. So remember, we take an I out, and then that becomes the square root of regular 24. And then I break down that 24 into 2 numbers that multiply to 24, where one of them is a perfect square. So I'm going to use 4 and 6 because I know that 4 is a perfect square. So then on my next line down, I'm going to have 6 plus or minus. The square root of 4 is 2. I join that with the I, and I keep the radical 6 over 6. All right, and now I'm almost done. They want it in A plus BI form. You can see that all 4 choices have that. So what I'm basically going to do is I'm going to take this first, and that, if I divide that, is 1 plus or minus. And then what I'm going to do is I'm going to do, these guys right here. And 2/6, if you reduce that, is 1/3. So that's radical 6 with the I over 3. Technically, the 1 is here, okay? And then you can see that this is your 1/3 that I would get right here. You don't have to write that, and obviously it's not written here. Number 11, the answer is choice 4. You're starting with 1,000 bacteria. So all of these start with 1,000. Okay, now here's the thing. We are tripling. So we should see a 3 in the parentheses. That being the case, then, we can cross off choice 1 because there is no 3 in the parentheses. So what it comes down to is what we're seeing here as the exponent. Do we have a t? Do we have a 10t? Do we have a t over 10? Okay, and most kids will come up to the conclusion that choice 2 isn't it because there's no 10 involved at all, and this says it triples every 10 hours. Now, think about this. This is where it becomes a little tricky because a lot of kids choose this one. They're like, well, there's a 10, but this is tripling once every 10 hours. Once every 10 hours. Okay, so what this really means, if you really want to know, okay, what this really means is I'm going to write t over 10 is the same thing as 1/10 t, okay, because technically there's a 1 here. All right, so what t stands for hours, if you read it right here. So this is saying it's tripling 1/10 in an hour. 1/10 in an hour, which means 2/10 in 2 hours, 3/10 in 3 hours, and so on and so on. So there's a complete tripling after 10 hours. So in 1 hour, it's not fully tripled yet, if that makes any sense. So I'm going to try that one more time. That bacteria triples every 10 hours. So it's fully tripled after 10 hours, which means in 1 hour, it's not fully tripled. It's only 1/10 of the way there. Okay, and then after 2 hours, it's 2/10 of the way there. And after 3 hours, it's 3/10 of the way there, and so on and so on. And finally, after 10 hours, it's 10/10 of the way there, which is fully tripled. 10/10 is a whole. Okay, number 12, the answer is choice 4. They asked for recursive, so I know it can't be 1 or 3 because recursive is always 2 equations. Okay, now the other thing is it's talking about an initial investment of $5,000 and it's earning 3.5% interest. So if you're earning interest, that means you have the full value of what you started with, which is your $5,000, plus your 3.5%. Okay, so think about it this way. Remember that good old formula, A equals P times 1 plus R to the T. And here we go right there. So it should be 1 plus the 3.5%. 1 plus 3.5%. And that gives you this. This is just the actual interest. It's not the whole amount. 13, the answer is choice 1. 13 is a doozy. If I were you, I would definitely cheat on this one. So you have X values and Y values. So probably what I would do is I would do 2 store as X, and then I would do 3 store as Y. Now remember, we don't have a Y button, but we kind of do have a Y button. So what you're going to do is you'll hit 3, hit the store button, and then your Y is above the 1. If you look on your calculator, it's above the 1 in green. Hit that. Okay, and then after you do that, type in this whole thing very carefully into your calculator. You're going to get a number, and then type in your answer choices and see which one gives you the same number, and it's choice 1. Number 14, the answer is choice 3. All right, so I started by putting k of x into my y equals, and here's the graph that I got over here on the right-hand side. Okay, so the first thing that I'm going to do is I'm going to look at Roman numeral 1, and it says x minus 3 is a factor of k of x. Well, right here, I have a 0 at x equals negative 3. So this is the x-intercept. If x equals negative 3 is a 0, then its factor should be x plus 3. You change the sign. So this is not true. Okay, Roman numeral 2. It says k of 0 equals 9. Really all that's saying is that k contains the point 0, 9, where you can, if you have this typed into your y1, just go to the table and look at when x is equal to 0, and you will see y is equal to 9, which is what I have right here. So Roman numeral 2 is true. All right, the last thing is this k of x over x plus 2 has a remainder of 5. Well, that's interesting. What that really means is if I were to plug in x equals negative 2 into my k of x equation, I should get 5. Okay, so let me show you. So k of negative 2 equals negative 2 times negative 2 cubed minus 11 times negative 2 squared minus 12 times negative 2 plus 9. And you work that out. Now, of course, I like to just do negative 2 store as x and then type this whole expression in, because that way, if you try to do this by hand, a lot of times you can make silly mistakes. So when you end up doing that, you end up getting 5, and that is true. And that's why the answer is choice 3. Number 15, the answer is choice 4. I would cheat on this one. So they give you this equation. I would do 2 store as x. Then I would type in that equation, get a number, and then type in all 4 of these answer choices and see which one gives you the same number, which would be choice 4. Number 16, the answer is choice 4. Okay, so if you read this through, they're telling you that 49% of the students use beta math. So I'm going to use B for beta math. And so the probability of beta math is 0.49. And then they're saying 68% of his students used beta math. All right, so I think I just messed this one up. All right, let me just go back a quick sec. I'm sorry, on the first of the 49%, use beta math and past. So let's try that again. Beta math and past, P for past, is 49%. And then 68% used beta math. So that's just beta math alone would be 0.68. Now let's read the question. It says, approximately what percentage of Mr. Zachary's students passed, P for passed, given that they used beta math? That's what we want to find out. So the formula for given is the probability of P and B over the probability of B. That's the formula. So now all I'm going to do is take my probability of past and beta math, which is the same as this. Okay, the order of these letters don't matter for ands. And so that's going to be 0.49 over 0.68, and then just throw that in your calculator. Number 17 is choice 1. All right, so we have something that's terminating in quadrant 2, an angle. So remember, we always like to draw from the origin into the quadrant that they're referring to, which is in quadrant 2. So here we go. And I always like to take the end of that terminal side, and I'm going to form a triangle, always to the x-axis. So I'm going to go straight down. And theta is always that angle in the corner by the origin. Be careful that from here that you didn't go this way, because that would be drawing to the y-axis. We always draw to the x-axis, and again, theta will always be in the corner by that origin there. They gave me sine, which I know is the opposite over the hypotenuse. And it's always in reference to the angle. So I'm going to start here, and I'm going to draw, I like to draw an arrow to the opposite side. So this is my opposite, so I put a 7 here. This is my hypotenuse, so my hypotenuse will be this side right here, which is 25. Okay, all right. Now, what they're asking for is the value of tangent. I know that tangent is the opposite over the adjacent. The problem that I have here is I don't have this adjacent side. I have 7, I have 25, but I don't have this side, and I need it to answer this question. So then we're going to go back, and we are going to do a squared plus b squared equals c squared. Whenever you're missing one side of a right triangle, we can do this to find the other side. So I'm going to put 7 squared in here. B squared is what I don't know, and I know c squared is 25 squared. So I'm just going to subtract over this 7 squared and throw that into the calculator. And that will give me 576. Then I'm just going to take the square root of both sides, and b will be 24. So that 24 is going to go right up there. Okay, so we're looking for the tangent of theta. So tangent is the opposite over the adjacent. Now be really careful here, because why is it that I just wrote this, but my answer is in choice 3? And that's a really good question and a really good point, and something that we have to be very careful with. So the other thing that you're supposed to remember when you learned all of this trig stuff is all students take calculus. And currently, I'm in the second quadrant, and the only thing that's ever positive in the second quadrant is sine and its reciprocal trig function, which is cosecant. I don't have that. So if sine and cosecant are the only things that are positive in the second quadrant, tangent not being one of those two things, this has to be negative. So that's why the answer is choice 1 and not choice 3. 18, the answer is choice 4. All right, so I underline some very important things for a question like this. Whenever they talk about normally distributed, whenever they give you a mean, whenever they give you a standard deviation, whenever they ask for either a percentage of people or how many people, and then after that, they may say something, like let's say in this case, it's talking about younger than Ryan. They may say older than Ryan. They may say between this age and this age. That's your normal CDF. All of those things are a little clue that we're going to be doing normal CDF. And when you do normal CDF, remember that you're going to hit your second button, and then you're going to hit your VARS button, which is just next to your clear button. And you'll see it's number 2. So we hit that, and then you're going to be given a lower bound, an upper, right? So let's write this down. So we're going to have a lower and an upper. We're going to talk about that in a second. Then we've got that funky symbol. Remember, this symbol just really is your mean. So in this case, our mean is 36. Then you have this symbol, and that's really just your standard deviation, which they told us was 6.2, right? Okay, so let's talk about lower and upper. In this case, they are referring or comparing other people that work at the store that might be younger than Ryan. Okay, so younger than Ryan would be people that are younger than 30. So would 30 be your lower or your upper if these people are younger than Ryan? Okay, so Ryan's age should be the higher. They want to see how many people are lower than him. So 30 will go here. and I like to exaggerate, so I pick a really, really low number, negative 999, just what I like to do. And then you throw all this into your calculator, keep hitting enter, and you should end up with 0.1665. Now be very careful. Sometimes the question, like here, the question will be asking, what percentage of people who work at the store would you expect to be younger than Ryan? If that's the case, then the answer would be 16.65%. They're not asking for the percentage of people, they're asking for how many people. So this is the percentage of people that are younger than Ryan, and what we're going to do is we're going to find the number of people that they employ, which is a total of 49. So if they ask for how many, all you do is you take this percentage and you multiply it by the total number of people that they employ, and that would be 8.1627, which ends up being choice 4. Number 19, the answer is choice 4. Okay, so they want an inverse function. So d of x is really just a fancy way of saying y. And so when we want to find an inverse, all we have to do is take this equation and we're going to switch the x and the y. So instead of writing y equals, I'm going to write x equals. Instead of writing the cube root of x plus 2, I'm going to write the cube root of y plus 2. And there technically is your inverse. The problem is if you look at the 4 answer choices, none of those match what I have just written down in black. So what I'm going to do is I always like to get the y by itself. So the easiest way that I'm going to get the y by itself is I want to get rid of that cube root because it's yucky. So I'm going to do the opposite, which is cubing. What I do to one side, I do to the other. I'll be left with x cubed on the left side, and the cube and the cube root are going to cancel each other out, and I just have y plus 2. Now I just need to get the y by itself, so I'm going to subtract 2 from both sides, and that will give me x cubed minus 2 equals y. Now technically, as an inverse, we would write that d to the negative 1 of x, and there you go. Number 20, the answer is choice 3. Okay, so if I know that f of 3 is equal to 0, that means that x minus 3, notice I changed the sign, is a factor. So my goal is to take my f of x equation, this whole thing, and divide it by x minus 3. Because then maybe I can get it down to something that I can actually factor and figure out what the actual remaining zeros would be. So I'm going to take the x minus 3 and I'm going to divide it into the f of x equation. Okay, so up here I will get x cubed, and then I will multiply that x cubed by the x minus 3 each term, and I'm going to get x to the 4th minus 3x squared. Oops, 3x cubed, sorry. Okay, and I'm going to subtract. So that's going to leave me with 3. My goodness, what's happening here? That's going to leave me with 4x cubed. Bring down the next term. So up here, I'm going to have 4x squared. And then I'm going to multiply that times the x minus 3. And I'm going to get 4x cubed minus 12x squared. And I'm going to subtract. Okay, so then with that, I am going to end up with 9x squared because I'm doing negative 3. This will cancel out. I'm doing negative 3 minus negative 12, which will leave me with 9x squared. And then I bring down the next term. All right, so then that leaves me with a 9x. And then I'm going to multiply that 9x times the x minus 3, which is going to give me 9x squared, and then minus 27x. and I'm subtracting that. This will cancel out. And then I'm doing 9 minus negative 27, which will be a positive 36x. And I'm bringing down that negative 108. Okay, so then when I do that, I am going to have a plus 36 here. I'm going to multiply that by the x and the minus 3, and that leaves me with, oops, that, and when I subtract, those are gone. Okay. Now what I'm doing is I'm taking what I got by doing this long division, and I just rewrote it down here, and I'm going to factor that. So it's a 4-term polynomial, so I'm going to find a GCF, which would be x squared, and then x plus 4. And then over here, I'm going to take out a 9, and I'll have x plus 4. So I have x squared plus 9, and then the x plus 4. Okay, so this one right here, I know one of its zeros would be x equals negative 4, right? We changed the sign. So currently then, let me get my pointer out, I know that I have x equals 3 as an answer, which I've got here. And now I have x equals negative 4 as an answer, which I have here. Okay. All right, let's talk about this though, because I cannot factor that. That's not the difference of two perfect squares. That's the sum of two perfect squares. So the way I like to do that is just take it and let's set it equal to 0. So if I move that 9 over, I'm getting x squared equals negative 9. And to get the x by itself, I would take the square root and the square root. But remember, when you take a square root, you should always have a plus or minus. And then the square root of negative 9, well, the square root of a negative number is an I, and the square root of 9 is 3. Okay, and that's how we get choice 3. Number 21 is choice 3. And if you look at what I underlined, you are subtracting the cost function is found by subtracting the cost function, c of x, from the revenue function, r of x. So it wants to know which function below represents the cost function, given that you have p of x here and you have r of x there. So essentially, profit is found by subtracting the cost from the revenue. Now be careful, when it says from, that means whatever was spoken about first actually gets written last. So here we go. But if you look down here, they want to know what is the cost function. So I'm going to try to get the c of x by itself. So I'm going to move the c of x over here because it's negative. So if I move it over here, it's positive. Okay, and at the same time, I'm going to take this p of x and I'm moving it over here. Well, right now it's positive, so if I move it over here, it becomes negative. Okay, so if I move the c of x over to the left, it becomes its opposite sign. Again, it's negative here, so now it's positive because opposite sign equals, I'm not moving r of x, so I'm just going to leave that. And now I'm going to move p of x over to this side. It's positive now, so when I move it over to the other side of the equal sign, it becomes negative. So then all you're really doing is you're taking this equation right here, which is your r of x. So let me just write that down. So here's my r of x minus your p of x. So we would double distribute. Not just double distribute, distribute. So this would become a positive 15x squared. This will become a negative 600x. And this will become a negative 60. And then you just add your like terms. And this is what you'll end up with. Okay, 22, the answer is choice 4. All they really want is the remainder. So when you have a factor that a polynomial is being divided by, remember it's 0 would be x equals positive 2. You switch the sign. So we can do this two ways. We can do long division. We can divide this polynomial by x minus 2, kind of like what we did up here. Or we can just take 2 and let's plug it in here. According to the remainder theorem, if you have a function, we can find its remainder by plugging that value, x equals 2, in. Okay, so again, I changed the sign to get x equals 2, and then I'm just plugging in a 2 here, and then I work it out. Okay, now you can do 2 store as x, and then type this in. That would be a lot easier. That's up to you, but you end up with 29. Number 23, the answer is choice 3. All right, so here are the fun ones. I know that this equation is going to be a y equals, and notice that the x is the thing that's squared. Okay, so if you recall, the formula generally is y equals 1 over 4p times x minus h, that quantity squared, plus k. Basically meaning I want to get y by itself. So I'm going to start by dividing by 12. And then I'm going to write y plus 1 equals 1/12 x minus 4, that quantity squared. Now, I like to do that. I could write this just divided by 12 as you see it, but I like to write it like this because I want it to mimic this guy. Okay, so now let's look at this. The denominator is 4p, and these two are equal to each other. So do you see that p would have to be a 3, because 4 times 3 will be 12. Okay, all right, I'm going to talk about that again in just a second. Give me a second here. All right, so then I'm going to just come up here because I want to get the y by itself. So I'm going to move that 1 over. So this is going to be 1/12 x minus 4, that quantity squared. And if I move that 1 over, it becomes a minus 1, right? All right, so let's go back to this again. Remember, p is going to be equal to 3. The next thing that we have to look at, and let me change colors here so you can see it a little bit better, is right there. Okay, that helps you find your vertex. So your vertex is going to be positive 4. We always change the sign of the number inside the parentheses, and negative 1. The negative 1 is not in parentheses, so we don't change that sign. All right, so I like to draw a picture because I don't know how well you can succeed at this question without it. Okay, so we've got 1, 2, 3, 4, negative 1. So there's my vertex, 4, negative 1. I'm going to draw the parabola, and since this is a positive 1/12 and not a negative 1/12, I know that my parabola is going to be pointing up. Okay, so it's going to look something like that-ish. All right, now p is 3. So what that means is from that vertex, I'm going to go up a distance of 3. So let me just show you. I'm here right now. 1, 2, 3. And I'm going to put a point right there. And that is my focus. And then what I'm going to do is from here, I'm going to go down 3. Okay, so let me put some little slashy things there. Boom, boom, boom. So from here, I'm going down 1, 2, 3, and I'm going to draw my directrix, which is that line. Okay, so this, I'm going to write D for directrix. And if you look at that, that's down at 1, 2, 3, negative 4. Okay, and you can see, we can look at the options that we have here. We do not have a vertex of 4, 2. Our vertex is 4, negative 1. The focus is not 4, negative 1. The vertex is. This is the focus. The focus is 4, positive 2. Okay, see how they switch these guys up? The directrix is y equals -4. And we can see that this is also not true as well. All right, 24, the answer is choice 4. Now, if you read the last sentence, it says approximately how many miles total. So total is that formula S sub n, and you get that formula. Remember, it's a sub 1 minus a sub 1 times r to the n over 1 minus r. Okay? All right, so we're just going to figure this out. So we're starting with a distance of, oh, he wrote 10 miles initially, right? 10 minus 10. And we are increasing by 9% each week. So remember, that would be 1.09. We add to 1. And then down here, I'm going to have 1 minus 1.09. And then it says approximately how many miles total will he have ridden from the beginning of his training to the end of the 15th week. So that means your n is 15. And you just put this in the calculator. So they're more than just one part. Okay, student body, so you would have to have more than just looking at graph up here. The first bullet point over here is that there are zeros at -5, and second bullet point, as x goes to infinity, meaning the right side of the graph goes down. And meaning, and then the third bullet point is the left side of the graph also goes down. Like that. Okay. Now, for what I'm going to do, now that's one option. Let me show you another option. Okay, so here's another option here that you can do. You see that I bound here at -5 as opposed to bouncing here at +1. But notice that my two ends are still going down, and I still have 3 zeros as opposed to the 3 ends. Okay. Now you could also have bounced here that okay, so there's more than one option here. By definition, the period of a graph here is how long it takes for, in this case, the Ferris wheel car to make one full cycle. So if you have a Ferris wheel, usually maybe you'll start down here. Here's the grass. Okay, and then you start going around, 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 and around. And you land right back where you started at this little stand here. Okay, and that's technically what's happening in one period, how long it takes to get around one full cycle. All right, so the way that we find the period of a graph is it's 2 pi over the frequency. And the frequency is always the number in front of the x. So in this case, that's that 2 pi over 5. So I'm going to do 2 pi over 2 pi over 5. Now, I'm going to do keep change flip. So I'm going to keep my numerator, which is 2 pi, change that division, this, to multiplication, and then I'm going to flip that guy. So I'm going to put that 5 over 2 pi over here. And technically, this is over 1. So if you look at this, when we multiply fractions, we multiply numerator with numerator, denominator with denominator. Okay, so we get 10 pi over 2 pi. The pi's will cancel out, and 10 divided by 2 is 5. Okay, so what is the answer to this question? Well, the first part is they wanted to know what the period is, and the period is 5. Now, time is measured in minutes, so that would be 5 minutes. It does say to describe what the period represents in this context, so there's my sentence. It takes 5 minutes for the Ferris wheel to make one complete cycle around. Okay, number 30. The answer is x equals -3 and x equals -1. All right. So I'm going to just start by spreading it out a little bit. I need to find a common denominator, and I need to find a common denominator of all 3 things. Okay, I just put the 5 over 1. Now, this x plus 5 is a binomial. It's like it's in parentheses. So this x here is a monomial. So that's different than this one. Okay, so if this is a monomial and this is a binomial, and I want to find a common denominator, because the one is sort of, I don't want to say irrelevant, but it's just going to go along for the ride. I would need to multiply both the top and the bottom by x. And then in the next fraction, I would need to multiply the top and the bottom by x plus 5. So I'm not done yet, but let's just pause. Now, do you see that this is x plus 5, and this is x plus 5? Okay, because this is a monomial, this is a binomial, they're two different things. All right, but over here, this is still a 1, so that needs to get multiplied by x and x plus 5 so that it matches the other two guys, which means this needs to get multiplied by x and x plus 5. Okay, so once you have an equation and all three denominators match and you have appropriately multiplied your numerator by the factor that you're multiplying by, we can cancel out these denominators. So I'm just going to go through and I'm just going to go like this. They're all gone now. Okay, so then really all that we have is we have 8x minus 3 times x plus 5 equals 5x times x plus 5. And now I'm just going to distribute here, and I'm going to distribute here, and let's see what we get here. So we have 8x minus 3x minus 15 equals 5x squared plus 25x. Okay, and as I've said before throughout this video, anything with an x squared, I want all this stuff to come over to that side. But before that, I see that these are like terms, so I'm just going to quickly add those. So that's going to be 5x minus 15 equals 5x squared plus 25x. So I'm going to subtract 5x, subtract 5x. Then I'm going to add 15, and I'm going to add 15. So that's gone. So essentially then what I have left is I have 5x squared plus 20x plus 15 equals 0. Now, if you look at all three terms there in number 30, they all have a common factor of 5. So I'm going to divide all of this by 5. Now I'm running out of room, so I'm going to throw it up over here. So 5x squared divided by 5 is just x squared. 5 divided into 20x is just plus 4x. And then 15 divided by 5 is plus 3 equals 0. Then I'm going to factor. So what adds to 4 and multiplies to 3? So that would be 3 and 1. And I need a positive 4 when I add. So both those signs are going to be positive. And then again, you just want to double check. So these both add to positive 4 and they multiply to positive 3. So I know that I'm good there. Okay. And then from there, I have x equals negative 3 and I have x equals negative 1. Okay. Please be careful. For this particular question, we're correct. Those are our answers. However, you should always check your answers for extraneous roots. And all that means is, I'm going to take this negative 3. If I put a negative 3 in here, will I get 0 in the denominator? And the answer is no. So that means this is okay. But I also want to put negative 3 here. Will I get 0 here? No. So that's an answer. Same thing with negative 1. If I put it here, I don't get 0. And if I put it here, I don't get 0. So both of these would be our answer. Now, let's talk about this for a quick second. A number that would make this 0 would be negative 5. So if I had negative 5 as one of my answers, I would have to reject that answer. Just like if I had x equals 0 as one of my answers, I would have to reject that one as well. I'm going to use J for junior and D for driving to school. And they want to know if they're independent. So the rule for independent is probability of J and D equals the probability of J times the probability of D. If the two, the left and the right hand side, are equal to one another, then they are independent. If they're not, then they're not. Okay, probability of a junior and driving. So junior and driving, there are 58 juniors that drive. So that would be 58 over, and then we add up all the numbers in this chart, all 6 of them, and we're going to end up with 277. All right, probability of juniors. So juniors would be this entire row across, so 58, 75, and 12. And we would add those up, and there are 145 of those. And again, always out of the entire total, which is 277. Okay, how many people drive? So that would be this column right here. We add those guys up, and that's 139 over 277. All right, so you can do this a bunch of different ways. I did 58 divided by 277, and I got 0.2093. And then I multiplied this entire right-hand side right here, and I got the decimal equivalent, and I ended up getting 0.2626. Clearly, those are not equal to each other, so then your answer is not independent. That's it. All right, so here is my answer. So what I started by doing was I graphed that, and this is basically what it looks like, and we're hitting the y-axis at 7. An odd function is a function that maps onto itself when you rotate it 180 degrees about the origin. Simply put, let me just give you an easier example. Let's say we just had regular y equals x cubed. Okay, so this is y equals x cubed. If you were to take this picture and put it on a piece of paper right now, and then take your paper and just turn your paper upside down, rotate it 180 degrees, do you see, if you do that, your graph is still going to be going up on the right side. It's above the x-axis. It goes through the origin also. And then it goes down below the x-axis on the left-hand side. Okay, so if you turn this picture 180 degrees, you're looking at the same exact thing as what I'm looking at right now, right side up. When you rotate this guy 180 degrees, that is not the case. This will not look exactly the same when you rotate it 180 degrees. This point ends up down here, okay? And then this piece ends up going like this, and that piece ends up going like that, right? So this is not an odd function. All right, so I started with cheating and putting this into my calculator using that second matrix option, because I know I need to show work for this question, but as I go along, I just want to make sure I have the right answers. So I always suggest to students to take that cheating method and just know what your answers are going to be before you start. Okay, so I'm going to look and I see x's are lined up, y's are lined up, and z's are lined up. And then we have the equal sign and the numbers. Once we have that, we can get moving here. Now, it's really up to you which letter you want to get rid of. It does not matter. I think I am going to start by getting rid of the x's, okay? So what I like to do first, and I highly suggest, I like to label each equation A, B, and C. Then I label a step 1, and then I write down 2 equations that I'm choosing, okay? I chose A and C. Now, looking at A and C then, I know that if I multiply A by 2, that's going to get rid of my x's. I always highly suggest that you go off to the right here, and let's write down what I get for A now. So A, I get 6x minus 16y plus 4z equals negative 120. And then we just didn't do anything to C, so we're going to write negative 6x plus 2y minus 4z equals 36. All right, now let's look and see what I have here. Okay, so if I go like this cancels out. Oh my goodness, look what also happens. My z's cancel out. Now, I was working with a student who actually said to me, I made a mistake because I get 2 letters that cancel out. Guess what? That's a bonus. Happy birthday to you. Sometimes that happens, and that's great because it makes your life just a teeny bit easier. So what we're going to do now is we're just going to add our like. And by doing so, you will see that I end up with negative 14y equals negative 84. Divide that negative 14 out, and I get positive 6. So bingo, look at that. I know that I did it right. Okay, and that's why the cheating helps, is especially like for the student that I was working with, he was very confused by the fact that two letters canceled out. But I said, just, he's very good algebraically, so I said, just keep going and look, it does end up checking. So you're good to go here. All right, so now that we know that y is equal to 6, that helps, you know, a little bit. So I'm going to continue along my train of thought of getting rid of x. So I chose equation B and equation C. And I'm going to take equation B and I'm going to multiply it by 3 because, again, that's going to get rid of that x. All right, so here we go. So when I do that, I end up with 6x minus 21y. What do we got there? Minus 15z equals negative 93. And then here I end up with 6x plus 2y minus 4z equals 36 because I didn't do anything to c. All right, now, whoops, this is supposed to be a negative, isn't it? Okay, we're going to now just add our like terms. And here's what we end up getting. Now remember, we know what y is. So at this point right here, I can go negative 19. I can plug in my 6 minus 19z equals negative 57. And now I'm just going to simplify that. And then you can see that as I progress through, okay, here, I got negative 114 minus 19z equals negative 57. I added 114, got 57. Then I divided out, and I got z equals negative 3, which matches that guy. Okay. All right, so then now that I have that, all I have to do now is find x. So you really, at this point, you can choose any equation, any of the original equations that you want. It really doesn't matter. So I'm going to squeeze in, I'm going to squeeze in, let's try that again. Let's see if I can, there we go. There we go. Sorry about that. Step 3. And I am going to do, I'm going to do B. Okay, so I've got 2x minus 7 times my y, which is 6, minus 5 times negative 3, because that's my z, equals negative 31. So this is 2x minus 42 plus 15 equals negative 31. And then you can see that I just added these guys. I got negative 27. And now I'm adding 27 to that other side. Okay, so that's going to give me 2x equals negative 4. And then I just divide by 2. And there's my last variable. X equals negative 2. All right, and there's our 3 answers. Okay, so let's just say for number 33, you did not get 2 letters to cancel out on that step 1 that I did. Okay, and to be honest with you, the first time I did this question, the same exact thing happened. I didn't get 2 letters to cancel out like I did on the last one where I got the X and the Z to cancel out. So I'm going to show you how to handle that if that were to happen. So if I look at my step 1, this time I'm still going to get rid of X's. That's my choice. But I'm going to get rid of, I'm going to use equation A and equation B. So I'm going to make this one multiplied by negative 2, and this one is going to get multiplied by 3. And then hopefully you'll see that this will be a negative 6 and this will be a positive 6, and they'll cancel out. I chose this one to be negative. I could have chosen that one to be negative. It really doesn't matter. Okay, so let's follow over to the right, and I'm going to get negative 6x plus 16y minus 4z equals 120. And then for this guy, I'm going to get a positive 6x minus 21y minus 15z equals negative 93. Okay, now let's add the two equations. Those will disappear. Here I end up with negative 5y minus 19z equals 27. Now do you see there, what I did was I reduced two equations that each had 1, 2, 3 variables, right? 1, 2, 3 variables, and now I have one equation with just 2 variables. Okay, I'm going to call that equation D. Now, our goal is to do that again. So in a normal set of circumstances, unlike what I just showed you on the previous page, you would be doing, step one, I was able to whittle it down to just finding that one variable. Normally what's going to happen is you're basically going to repeat step one again in step two, meaning that I'm going to try to take two equations and make it end up to one equation with just a y and a z in it. So I'm going to go back here and I'm going to pick, in this instance, I'm going to choose equation B and equation C. Again, still getting rid of the same letter. You must, in step one and step two, get rid of the same variable both times. Okay, so this one then, I'm going to need to multiply by a 3. All right, so if I do that, I end up with 6x minus 21y minus 15z equals negative 93. And then this one is a positive 6x, I'm sorry, negative 6x plus 2y minus 4z equals 36. Let's add like terms, those are gone. So for my equation E, I have negative 19y minus 19z equals negative 57. And you can see, let's just take a moment and compare y, y, z, z. So step one, step two, same thing. Pick, group two together, get it down to 2 variables, group 2 different ones together, get it down to 2 variables. So for step 3, what I did was I took D and E, the equations that I got from step 1 and step 2, and I just wrote them underneath each other. And now what I'm going to do is essentially what I did here in step 1 and step 2. I'm going to try to get rid of one of these variables. Now, right away, I'm looking at this and I'm like, oh my goodness, these are almost identical except that one's negative. Actually, except they're both negative. So I'm just going to, let me get my red going here. I'm just going to take this one and I'm going to multiply by negative 1. So my D equation is going to stay the same, negative 5y minus 19z equals 27. And then here, I'm going to have a positive 19y, a positive 19z, and then a positive 57. And then you can see that your z's are going to cancel out. So then I'm going to add these guys, and that's 14y. And I'm going to add those two numbers at the end there, and I get 84. And then when I divide by 14, right, divide both sides by 14, I get y equals 6. And there's my first variable. Okay. All right, so now in step 4, what you do is you make a choice and you can either go back to equation D or equation E. So I just chose equation D. It really does not matter. And I'm going to plug in my y value that I got in step 3. So negative 5 times 6 minus 19z equals 27. So this is negative 30 minus 19z equals 27. And then I'm going to add 30 over. And that's going to give me negative 19z equals 57. and then I'm going to divide out that negative 19, and then my z ends up being negative 3. Okay, last step, step 5. So now with step 5, you see that we have y equals 6 and we have z equals negative 3. So you can just go back up and you can choose any equation that you like from the 3 originals. Okay, so like for example, I could choose the first one, which was equation A, and do 3x minus 8y plus 2z equals negative 60. And then I'm just going to be solving for x, right? Because I don't know what x is. And I know that y is 6. I know that z is negative 3. And there's the rest of that solution. Okay, so I just multiplied these two guys, added these two together, added that negative 54, or made a positive 54 over negative 6, and divided. So there's your other option if you don't get two variables canceling out on that first initial step. Okay, so in number 34, they're asking you to determine the average rate of change, which is the same as the slope. So here's the slope formula, but they want it from 2010 to 2018. All right. So you have to reread the question, and you will see that the question says that the house prices since 2008 have changed based upon that function. So 2008 to 2010, that means that here t is going to be 2. And 2008 to 2018 means t is going to be 10. So what we have to start by finding is we have this equation right here. My suggestion would be if you put that in your y1, and then all you have to do is go to your table of values, and you can look up when x is 2 and when x is 10, and then you'll know what the y values are to put in there. And so when you look those up, again, this is in your y1, and you go to the table and you go down to a value of 10, this is the y value that corresponds with that x value. Okay, and the same thing here, then go down to when x is 2, and that's the y value that corresponds with that. Okay, and then your denominator is just going to be x2 minus x1, so in other words, 10 minus 2. And then you just throw that whole thing into your calculator, and I get 11,523.6105. And it says to the nearest dollar is your ones place. So that would be 11,524, because that 6 is going to round that 3 up. Okay? All right, so now they're asking you to explain what this really means as it relates to the median house prices. We are having an increase, and you can see that this is how much a house is worth in 2010 versus in 2018. So you can see that there's an increase, and you can look at that in your table of values. As your x values get larger, so do your y values. So there's an increase in the median home prices. So the increase in median home prices changed. You should always say on average, because we are doing an average rate of change. So the increase in the median home prices changed on average $11,524 per year from 2010 to 2018. So you need to have on average, you need to have per year, and then you give that time frame that they're referring to in this particular question. So for number 35, I see up here, love when they give you that. We're going to end up using that. If you read part A, it says determine an interval containing the middle 95% of plausible values. So remember what that basically means is your mean plus or minus 2 standard deviations. Okay, so let's start. So we're first going to start with doing the mean minus 2 standard deviations. So the mean, they gave it to you, it's in that circle, is 0.795 minus 2 times standard deviation is 0.085. Then we're going to do the mean plus 2 standard deviations. So essentially the same thing as what we did just above this, except with a plus sign. 0.085. Well, let's put the decimal right there. There we go. And when I do the math, that's what I get. So your 95%, I call it a confidence interval, would be 0.625 to 0.965. This right here is your 95% confidence interval. So let's take a minute and just before we answer part B, this means that most data, 95% of your data is going to be between 0.625 and 0.965. That's most of the time. 95% of the data. Only 5% will be below the 0.625 or above the 0.965. Being out here is very unusual. Being in here is very usual. It's a very common occurrence. So if you read Part B, they're saying that the company is going to continue to manufacture both types of hockey pucks as long as the proportion of customers who buy both types of hockey pucks is above 0.6. So using this interval from Part A, explain whether or not they should continue to produce both types of hockey pucks. So I'm going to read this part again. They will continue to manufacture both types of pucks as long as the proportion of customers who buy both types is above 0.6. Well, wouldn't above 0.6 be in here, right? This is very common. It happens often. So if they are setting this standard of above 0.6, that's very reasonable. So yes. And then this would be my explanation. So yes, they should continue to produce both types of pucks because above 0.6, this is their wording right here, above 0.6 is in that 95% confidence interval. Now, if you forget that it's called the 95% confidence interval, you could just say that above 0.6 is in the interval from Part A, and that's sufficient. All right, so for this question, I would start by taking this equation, putting it into my y1, and remember that log base. If you hit math and you arrow all the way down, you'll see log base, and so you can put that subscript of 2 in there. Okay, so you put that in there and you get this a graph, and it kind of looks sort of weird on that left-hand side. If you go to your table, so hit second graph, you'll start to see that you've got this error at x equals 1, x equals 0, x equals -1, x equals -2, so on and so on, working our way toward those negative numbers. But at x equals 1 is the place on that table of values where that error starts. Okay, that's not a coincidence. You will always find that if you take whatever's in the parentheses next to that word log, if we take this and I set that equal to 0, that is where we're going to have our asymptote. Okay, and that's where the calculator can be helpful, but also not helpful because it doesn't show this asymptote, and you have to know this. All right, so basically then what's happening is that graph is going to get closer and closer to x equals 1, but it's not going to touch it. So let's just back up for a second. Go back to that table of values, and I see at x equals 2, I have 3. And x equals 3, I have the point y equals 4. And then I'm just picking the pretty points, 5, 5. So let me see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here, okay. And you can kind of arrow down. We could do 9, 6. How about that one? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So here we go. So here's the thing that you have to be careful of. I'm going to draw this part right here, and this is going to continue on. But the left part, this part right here, you have to be careful. This graph is going to come down, but it's not going to cross over that x equals 1. Okay, so be very careful of that. So it's going to look like that. And there is your graph of f of x. Okay, state the equation of the asymptote. That would be x equals 1. All right, now what it's now telling you to do is to take this equation here, and they're saying that that function is going to get reflected over the line y equals x. And then we have this new function. So this is a reflection in the line of y equals x of this equation. And they want you to state the equation of the asymptote of this one. Okay, don't overthink this. You should hopefully remember that when you reflect something in the line y equals x, that's an inverse. And an inverse means to switch the x and the y. So basically, here we go. If x equals 1 is the original function's asymptote, then all you have to do is switch the x and the y. So in other words, that's an x. Well, in the inverse, it's a y. And that's your answer. Okay, so I'm going to repeat that one more time just to make sure you got it. When you reflect something in the line y equals x, that's a fancy way of saying inverse. And inverse means we switch y and x. And that's what I just did right here. I switched y and x. All right, last question. So you have to read this through carefully, take your time, and sometimes maybe you got to read it through a couple of times, but they're talking about an air temperature of 73 degrees. And if you read below, that means that this is 73 degrees. Okay, then the liquid is 237 degrees. Okay, so 237 degrees is going to be that initial temperature. So that's going to be this guy right here, 237. Then it says 1.5 hours later, so time now has elapsed and gone by. The temperature of that liquid is 112 degrees, and that's 1.5 hours later. I'm going to underline that. We'll deal with that in a second. So here's my equation set up. 112, 73, 237 minus 73, and here's that 1.5. 1.5 hours later, 1.5. Why is that negative? Because that's what the equation says. Negate k times t. I don't know what k is, so I just negated t. Okay? All right, so all you're going to do at this point is a little bit of algebra. So I'm going to start by subtracting that 73 over. And at the same time, I'm going to subtract the 237 minus the 73 as well. All right, so this ends up being 39 equals 164 e to the negative 1.5k. Okay, I'm going to divide out that 164. And I'm not going to do anything with that. So I'm just going to leave that 39 over 164 equals e to the negative 1.5k. Now remember, we had something similar on another question on this Regents, in the sense that I need to find this exponent, specifically that k, but it is an exponent and I want it to come down in front, but I have an e. So the way I get that to come down is if I ln that base And what I do to one side, I have to do to the other. So I ln both those bases, okay? So over here, I'm just going to leave this as the ln of 39 over 164 equals, remember that cancels out, a negative 1.5, okay? And then I just divide by negative 1.5 and throw it in my calculator. And I end up with 0.9575. And it says to round it to the nearest thousandth, so that's 0.958. There's your answer. Okay, so for the second part here, it wants you to determine the temperature. So this is the temperature. So I'm just going to leave that as T of T. Using your value for K that we got on the second part, right? I mean, the first part rather, I'm sorry. So we have our initial temperature of 73 degrees. I subtracted those two numbers. That's the 164 that I got on the last part. E to the, now here is my K, and here is my T, because it says after 2.5 hours, so that's 2.5. Now all of this, you can just throw into your calculator all at once, and you're going to end up with T of T is equal to 88 degrees. Okay, so for this last part, it's saying that Megan needs that temperature to be 80 degrees Fahrenheit. So we know the temperature is going to be 80 degrees, but we need to determine to the nearest tenth of an hour how much time she has to wait to begin that experiment. So in other words, at what time will I eventually reach that 80 degrees? Okay. All right, so again, let's do some math here. So I'm going to subtract that 73 over, so minus 73 minus 73. And I end up with 7 equals 164 e to the negative 0.958 t. I'm going to divide out that 164, just like I did on that very first part. And I'm going to leave that as 7 over 64. I'm sorry, 7 over 164. 7 over 164 equals e to the negative 0.958 t. Now this is the third time you're seeing this on this Regents. Remember what you're supposed to do now. I'm trying to find that exponent, and that exponent is all the way up top there, and I want to bring it down. So that means I need to ln, because I have an e, and ln on the other side, and that is going to cancel out, right? So then I've got the ln of 7 over 164 equals negative 0.958 t. And to get the t by itself, we just divide. Let me stick that negative in there and throw that in your calculator. And I end up with t equals 3.2922. And it says to the nearest tenth, so that would be 3.3 hours.